Hello, everybody. How's it going? Still Tree. Good to see you there. I think I've got my chat messed up a little bit because it looks like it is to the side. I said I was going to fix this, and I guess I never did. Let me just edit this very quickly. Let's go ahead and just decrease this. And that should be good, almost, hopefully. Let's see. Okay, there we go. Grab that. And we should be good. Okay, so chat should show up on the actual background now. Anyways, what are we going to be doing today? We are going to be continuing in these Vulkan tutorials, hopefully getting to our triangle eventually. Yeah, okay. I was going to say, I hope we don't have to get to vertex buffers and everything to get to the triangle. But yeah, looks like we just need to get through presentation, graphics pipeline, and then drawing. And once we get through to here, we should have a triangle on the screen. That is the hope. So we'll see. Implody, how's it going? You are a Vulkan user for many years. If I have any questions, you can help me. Cool. I appreciate it. We'll see how this goes. Right now, it's basically just following this tutorial. We're going to see how it goes. I'm not looking to get too advanced with anything here yet, so we will see what happens. But yeah, I guess we should probably just jump right back into it from the last tutorial. What we got to was setting up a few different queue families. I've got a lot of logs coming out from the validation layer, which is a little bit strange, but they're informational mainly. And then I've got this one from Rockstar that we found out about earlier. Not quite sure what's going on there. But yeah, we will just continue from here and let's see how this goes. And Adrian DeWinter, thank you for subscribing for 4 months. Awesome. Thanks. Good to see you. Hopefully we can make some good progress in this stream. We'll see. Okay, so yep, Rockstar Games is still there. Still not sure why. Like I said, I think I probably uninstalled the game wrong or something and it just broke things. But it is what it is. I'm not too concerned about it. Okay. So you don't want to print verbose info. It's useless unless you're a layer developer. Oh, okay. I appreciate that insight. I was wondering because OpenGL is usually the same thing. It's like a little bit too verbose and it usually does not help me out there either. But I appreciate that. So let's go ahead and remove that very quickly and that'll help us out a little bit. Since I didn't actually write this code, I'm basically following the tutorial. It is a little bit harder to remember exactly how all this stuff is working and the function names and everything. Yeah, I'm going to have to like take another stab at this eventually where I just do things myself. But let's see. Okay, so we've got the error bit and we've got the warning bit. What else do we have? Because I do want to make sure we have info bit and then verbose. Okay, so we'll just do info bit here. And then we'll leave the verbose out of there. Okay, so copy that, paste that, and let's see if that cuts down the number of logs we've got to a little bit more of a manageable level. Cool, yeah, that's awesome. So those were all verbose, which means we really didn't need them. Awesome, cool. And now on to the window surface and the swap chain. I want to try and get through these two. We'll see how that goes. Okay, so since Vulkan is platform agnostic API, it cannot directly interface with the Windows system. That makes sense. To establish connection between Vulkan and the Windows system, we need to use the Windows system integration extensions. In this chapter, we'll discuss the first one, which is the Vkhr Surface, which exposes a Vkhr Surface object that represents an abstract type of surface to present rendered images to. The surface in our program will be backed by the window that we've already opened with GLFW. Cool. And this surface extension is an instance level extension, and we've already enabled it because it's included in the list returned by get required extensions. So just to refresh my memory a little bit, if we look at GLFW required, okay, get required extensions, This is a function that we wrote, and this essentially just gets a list of extensions that we want. Okay, and then GLFW required. So, and this is a function that GLFW gives us, which returns Vkhr Surface, which it says right here. Cool. So, and it includes some other WSI extensions that we'll use in the next couple of chapters. One thing that can make my life easier is dynamic rendering, Vulkan 1.3 feature, where you don't need frame buffers and render passes anymore. But render passes are fine too, just not really required on desktop. Nice. I'm probably like literally just going to follow along with this tutorial since this is my first time. I am pretty familiar with OpenGL, so like a lot of graphics concepts aren't that bad to me. And I think it's better just to get it. I mean, because eventually you're going to need render passes and stuff once you want to get to more complex things, and frame buffers are pretty important. At least in OpenGL, I use frame buffers and stuff a lot. Not really a concept of a render pass explicitly, but yeah, I do appreciate the insight though. We'll see how this goes. The window surface needs to be created right after the instance creation. Ever heard of WGPU? I have heard of it, but I've never looked into it. Rust Graphics API. That's why I haven't used it or looked into it, because I don't use Rust. Interesting. Maybe one day if I look into Rust, I'll eventually take a look at that. But right now we're doing C++ with a very C-style code. But yeah. Dynamic rendering is basically, hey, I'll just use those attachments now without having to predefine an object for it. Interesting. And there is a C binding. Oh, okay. Cool. It sounds like if it's a pure Rust with a C binding, I'm guessing it'd probably be better to just use Rust since it is built natively in there. I try to use libraries and stuff in their intended language because it just gets complicated trying to manage all that stuff. Like I know you could just use bindings and everything, and I know that's probably a little bit easier, but it's just once you get to things where it's like if you need to dig into the API or anything, it's just a lot easier to be familiar with the language that's written in and stuff. Yeah. And it's basically the way most desktop GPUs work. Dynamic rendering is basically just, hey, I'll use those attachments now without having to predefine an object for it, which is basically the way most desktop GPUs work. Interesting. Yeah, like I said, I'd like to go through the whole tutorial just to get an broad level of coverage over everything, since I'm not familiar with many of these concepts at all. And then that way I can get the broad overview, and then I can drill down when I need to and kind of get rid of things as I learn a little bit more about it and everything. But yeah, so this needs to be created right after the instance creation because it can actually influence the physical device selection. The reason we postpone this is because window surfaces are part of the larger topic of render targets and presentation. Should also be noted that window surfaces are an entirely optional component in Vulkan. If you just need off-screen rendering, Vulkan allows you to do that without hacks like creating an invisible window, which is necessary for OpenGL, of course. Okay, so that's kind of interesting too. So if you don't actually have like a window and everything, you can just omit this. That's cool. So start by adding a surface class member. We don't have a class, so we'll just plop it up here, and then I can write some abstractions a little bit later and stuff. Okay, so we want a Vkhr Surface. KHR. And this is our surface. And did I get that wrong? KHR, VK, oh, VK is underscore, or not capitalized. Yeah, once you have the broad overview, I'd recommend getting rid of render passes and frame buffers first and doing the necessary pipeline barriers instead. Okay, I'm going to have to eventually take some notes on this and stuff too. I'm not sure how far I'm going to go into this. This was just kind of like me dipping my toes in the water a little bit. But we'll see. And just trying to get more ideas and stuff about how graphics rendering and everything works. But yeah. So consider getting rid of render passes and frame buffers and focusing on pipeline barriers. In the beginning. I wish there was a good book for Vulkan. Like, I know OpenGL, I've been reading the OpenGL Super Bible, and that thing is actually amazing. So very thorough and very enlightening in all the different aspects and stuff. Okay, so although this Vkhr Surface object and its usage is platform agnostic, its creation isn't, because it depends on Windows system details. For example, it needs the hwind or the H module, or both, handles on the window. Therefore, it's platform-specific addition to the extension, which on Windows is called Win32 Surface and is also automatically included in the list. Okay. I'll demonstrate how this platform-specific extension can be used to create a surface on Windows, but we won't actually do it in this tutorial. It doesn't make any sense to use a library like GLFW and then proceed to use platform-specific code anyway. GLFW has GLFW create Windows Surface that handles this. To access native platform functions, you need to update the includes at the top. Okay, so he's going to show us like what we should do first, I think, because he said he's going to show how you could create manually yourself, but then you don't really need to do this. Let me just make sure. Okay, we'll now integrate it into our larger program, add a function, create surface to be called from the init Vulkan. Okay, yeah, so he's just kind of showing us what we could do instead. Yeah. Write down dynamic rendering as well there so you know what to look for. Good point. Let's do that. Look into dynamic rendering. I'll put that up here. OpenGL Super Bible is like the best tutorial book for OpenGL. Absolutely agreed. Red book is fine-ish, but blue book was so good. Yes, I think I have the red book. Actually, I think I have both. I've been reading through the blue book, but then I moved on to the red book because it was seemed like a better way to spend my time and stuff since it was the newer. But yeah, it's great. Let's see. So because a Windows Surface is a Vulkan object, it comes with this struct that needs to be filled in. It has two parameters, hwind and hinstance. These are the handles. Yep. Yeah, and then they're just using this to get the actual stuff. Okay, after that, surface can be created with vk create win32 surface, which includes this. This process is similar for platforms like Linux, but we can just use the GLFW create Windows Surface, which performs all that stuff except easier, which is what we're going to do now. So we're going to do that, and he calls it create surface. I guess we will do the same thing. So we'll have a static void create surface, and we'll put that right below this guy. And I think he puts it below that too. No, he creates it right after he sets up the debug messenger. Okay, I'm gonna have to do a lot of digging after I kind of dip my toes in the water to better understand this stuff, because once again, it doesn't seem like any of this is too complicated. It's just very verbose, and there's a lot of stuff that you just need to know about. Yeah. In any case, here's some further reading if you ever want any. Cool. Yeah, I kind of went on Vulkan's website and was just taking a look at the tutorials that they had listed, but this is interesting too. I will definitely leave this open just in case I want to take a look at it in the future. Okay, let's see, where were we? We're right here. And it looks like this is pretty simple. Except we're not going to throw a runtime error. We'll just say, what does it return? I think it returns it, UN32. Create window surface. And then we're going to give it our instance. Yeah, which I think I called window instance or something. I know I called it something different. I can't remember because it has been a week. So let's just go up here. VK instance is what I called it. So we'll do that. We have our window, which is our GLFW window. I think I just called that window. Allocator is null pointer, and then our surface, which we're going to pass a reference to. Okay, and then we'll just say glogger assert result equals vk success. And if it does not, then we failed to create window surface. All right. And if we run this, we should be fine. And we are indeed fine. So we've created our window surface all right, and we're continuing along a good line. And that's precisely it. Not very complicated, but super verbose. Yeah. So, which is fine. I mean, that's how a lot of programming is, but it just takes practice. And I feel like this is definitely part of that practice where it's just starting to do this stuff and learning about all the stuff that's necessary, and then eventually learning it better. So yeah, we also need to destroy the instance, which makes sense. Or I mean, to destroy the surface, we're already destroying the instance. So let's go ahead and do that, which I think I called this free. Yes. Okay. So before we destroy the instance, we'll say vk destroy surface khr, and we're going to give it our instance, and we're going to give it our surface and null pointer for our allocator. Cool. Make sure that the surface is destroyed before the instance. Okay. Querying for presentation support. Although Vulkan implementations may support Windows system integration, that does not mean that every device in the system supports it. Therefore, we need to extend is device suitable to ensure that a device can present images to the surface we created. Although the Vulkan implementation may support Windows system integration, it doesn't mean every device in the system supports it. Oh, okay. So this is basically saying we need to make sure the device can actually do the thing that we want it to do. Makes sense. So we're going to extend our is device suitable function to make sure that we can actually present images to the surface. Since the presentation is a queue specific feature, the problem is actually about finding a queue family that supports presenting to the surface we created. It's actually possible that the queue families support drawing commands and the ones supporting presentation don't overlap. Therefore, we have to take into account that there could be a distinct presentation queue by modifying the queue family indices structure. Wait, let me reread that. It's possible that the queue families support drawing commands and the ones supporting presentation don't overlap. Okay, so is he saying there is... Sounds like he's saying, so presentation is queue specific. It's possible that the queue family supporting drawing and presentation don't overlap. Okay, so it is possible that they do overlap too. Okay, we'll see how this goes. So anyways, we have present family inside of our queue family. So let's go up to that and we'll call you. And we'll just say, and that, and let's just take a look. Yeah, that sounds good. Still tree, the only good way to learn graphics programming is repetition. Yeah. This here is a wrong part from the Vulkan tutorial. There is no GPU that has no presentation support on the graphics queue. It's possible per spec. But there is no known GPU that has this ignore present family. Well, it's possible per spec. I don't know. There's no harm in doing it this way. I mean, if it is possible per spec, even if there doesn't exist any device that actually does this, it's better to have the right code than not. I don't know. I've been reading a lot of Raymond Chen's The Old New Thing, and he talks a lot about code assumptions that they've corrected for throughout the many years of Windows operating system development and stuff. So if the spec doesn't specify that this is true, then we'll just assume that the spec, it couldn't be true. I don't know. Nothing wrong with adding in a little bit of extra code to make sure your assertions are correct and stuff, in my opinion. But useful tidbit. Thank you. We'll modify the find queue families function to look for a queue family that has the capability. 100% of the time, present queue is graphics queue, and if it's not, going to be the async compute queue. Okay. Okay, I'm going to have to learn more before I can start parsing through the intricacies of all this different stuff and everything. For now, I don't think, from what you're saying, it doesn't sound like this will break the code. It's just saying that this is unnecessary, which I'll leave the unnecessary stuff in for now. But I do appreciate the insights. We'll modify find queue families to look for a queue family that has the capability of presenting to our Windows surface. Get physical device surface support queue. So you can just query graphics for present support, because multiple queues will make sync harder. Yes. once again, this is just a beginner tutorial, just trying to get to the triangle. The VK tutorial doesn't handle the possibility that the graphics queue does not equal the present queue later. Okay, but that's basically what I'm saying is beginner tutorial. I'm going to follow what the tutorial says. It doesn't sound like this is wrong. Synchronization is a whole nother topic and everything, and I'm probably not even going to be multi-threading this yet, so I'm not going to worry about that too much. But as I get deeper and deeper into learning this stuff, I'll probably go ahead and add different things like that. Yeah, so it doesn't seem like this is anything to be too concerned about. Then simply check the value of the Boolean and store the presentation family Q index. Okay. Which I believe we're doing inside of create logical device. Or possibly in here. Okay, yeah, so we do this and we say find Q families, and I think this is where this is happening. Yeah, okay, so right in here. Synchronizing GPU, not multiple threads. And the tutorial doesn't handle synchronizing the GPU to GPU, which is interesting. You get the whole lot of potential queue family ownership transfer shenanigans, which this tutorial does not handle. Okay. Once again, good information. I'm assuming this won't really matter though for drawing a triangle, which is the goal. So, yeah, I'll look more into the documentation and stuff later. It handles it with the assumption it's the same queue. Okay. Gotcha. So it's not even actually using it. If it's not the same queue, then it is bugged code. Yep, that makes sense if they're not actually handling for that. Okay, if it's not going to matter for a triangle, I'm not too worried about it at this point. But yeah, how's it going, Gelmega? Somehow while I'm in Belgium visiting my parents, still getting German ads. Google knows everything. Okay, so basically we're looking for present support. Okay, yeah. So oh, and he's using the index here. I was a little bit confused on what exactly he's doing here. Okay, so it looks like he's just doing this VK bool 32. And then he's just calling get device surface support. With the physical device, which I'm assuming we're passing in right there. Yeah. Okay. Q family index, which is going to be our family I. And surface. And that guy. Okay. Oh, and I think I see what you're saying now. So basically what he's not handling for is if this equals this. So if these are the same family, then you'd have to handle synchronization differently. Yeah, I see what you're saying here. Where did you learn Vulkan Implody? I'm curious because there are very few actual good resources. Using it and asking Vulkan Discord, graphics programming Discord when you are uncertain about some things. Also looking at some open source engines handle things and reading lots of blog posts like the one from the Maester. Nice. You need to go request a passport since you've been in 5 countries already and they were all in Schengen zone, so you need a passport there. Huh. Good job on getting a new job, Jamaica. Hopefully it's a good job and you enjoy it. I got a new job in like last November and have been enjoying it quite a bit so far. So it can be fun to have a little bit of a change in daily routines and stuff like that. Note that's very likely that, okay, yeah, so he mentions basically what you're talking about, Implody. These end up being the same queue family after all, but throughout the program, we will treat them as if they were separate queues for a uniform approach. Okay, so it sounds like he's going to actually treat them as if they're separate. Nevertheless, you could add logic to explicitly prefer a physical device that supports drawing and presentation in the same queue for improved performance, which makes sense. Okay, yeah. So you're basically saying you'd just have to synchronize a lot more if they actually weren't the same, which makes sense. Yeah. I mean, it wouldn't be very difficult to just add something to this guy, or not that guy, but this guy that basically just says present family, you know, basically just say like, I don't know, something like that. And then basically just do different things. Or just assert that it's true. And then if it's not, then just basically say that's not supported. There's a multitude of ways that I could handle that differently. For now, I'll just follow a tutorial. We'll see what he does for that synchronization. I'll add a note there, though, since this does seem like a good thing to have. Okay, so let's scroll back up here. And I'll put a to-do. The present family typically ends up being equal to the graphics family. Instead of adding synchronization for these, don't support separate queue families or add extra logic to handle when they are the same. I don't know, something like that, just to kind of give a note to myself. I'm not too worried about performance or anything like that. Once again, it's just a triangle, so it really doesn't matter too much. And Jomega, it's a tech support co-dev studio. While I can't mention something they're doing, it's public, that they are helping on Suicide Squad. Sweet, that's pretty cool. The handling is completely wrong later on if they are different. Okay. Well, we've got a note in there. I can always change it up later. The one thing that remains is modifying logical device creation procedure to create presentation queue and retrieve the queue handle. Add a member variable for the handle. Okay. Do I have a member variable for the other stuff, which in this case is just a global variable, or at least to this translation unit. Okay, yeah, so we do have a queue there. And we're going to have this. I wonder why they don't just put it in here. Okay. Next, we need to have multiple device queue create info structs to create a queue from both families. An elegant way to do that is to create a set of all unique queue families that are necessary for the required queues. And modify Vkhr create info to point to the vector. If the queue families are the same, then we only need to pass its index once. Finally, add a call to retrieve the queue handle. Okay. I feel like this is probably... Okay, wait. So if these are the same, then what's going to happen is I assume this set will truncate it so that this is just one thing. Queue priority equals 1. And then we get a bunch of create info. Okay, and then we put queue create infos.pushback. Sorry, just catching up on chat real quick. Okay, so let's go ahead and add this next little bit. So we have our indices, number of Q families, which I guess this is actually that, and we'll just get it from here. Oh, actually, I could just do this. Well, actually, that's probably gonna change up. So oh, okay, I see what they're doing now. So he's basically just going ahead and streamlining this thing. Makes sense. I may just use a set too, because that seems like the easiest way to do this. Okay, so let's go ahead and include set, and we'll just do the same thing. So basically, instead of doing it this way, we're gonna go ahead and do what he's doing there. And we'll just say this is equal to if it's gonna pick that up, indices dot, no, I'm not allowed to go based off that. Okay, graphics family and present family. Oh, wait, I have a set of the wrong thing. Do that, we will do this, and this is that. And this is that. Okay. And then he's just pushing it back there. Okay, so then I can just kind of do what I was doing before, except what we'll do is that equals that times that. Okay. So we do that, and then I'll just say for int I equals 0 until it's less than that. We do that, and we do that. Okay, and then this will just be I. Okay, cool. And I think that should be basically what we want. Yep, just create info. And I should probably zero initialize that stuff as well. So we'll zero initialize that. Create info, Q family, Q count. Oh, okay, and then for that, we're basically gonna use this index instead. Which it doesn't seem to like. Q family, which is this. Yeah, so we should be able to just index directly into that, unless you can't do that in a set. Unique indices, I. Oh, I guess that makes sense. Wait, what? Maybe? Okay, maybe I can't iterate through. I feel like you should be able to. Wait a second. Okay, std set array index. No, of course you can't. Okay, so we have to iterate through it instead, which we can do. So I'll do this, and we'll do that and scope it off. And then this we'll just switch up to Q family index. Okay, we'll do that. And this will just be this. And then we'll do an I++ at the end of that. Okay, So that should be the same. Q family index Q count is 1, which looks correct. And then we give it the priority, and then we just do that. And should we be pointing all of these priorities to the same thing? Does that matter? I guess not, because he's doing the same way. And I guess technically, once you create it right down here, it should be fine. Okay. So modify VK to point to the vector. So that should be easy enough. So he's basically just changing this to that. And then I guess we would just do that. Did I just call it that? I thought I had it up here somewhere. Oh, or just unique indices.size, which makes sense. Okay, so that should be fine. And then get device Q. If the Q families are the same, then we only need to pass its index once. Finally, add a call to retrieve the Q handle. Well, this doesn't seem very good. Okay, so we do logical device. Oh, okay, I see what's going on here. And then Q index. Oh, wait, yeah, this isn't very good. So he sets that to 0. So yeah, you're right. He is just going under the assumption that this is going to both be 0. Because if I understand this correctly, basically what we would want to do is to set this to 1 if this was actually the first index into this array. So, yeah, that's not very good. At least I don't think it is. Priorities don't matter and are only necessary to tune for explicit multi-queue performance tuning. Cool. Like having a background transfer queue and a dedicated fast transfer queue. Okay, interesting. What went wrong with Vulkan last time that you had to do it again? Oh, nothing went wrong. I just never got the triangle to the screen yet. Q index is 0. You'd set that to 1 if you want multiple queues from the same queue family. If you'd want multiple queues from the same queue family. So the way I assumed this worked was basically like if we had two queue create infos in here, right? We have 0 and 1, where 0 is our graphics queue and 1 is our present queue. Then down here, you would do 0 because that's pointing to the 0th index into this. And then 1 because that would be pointing to the first index into this. And I'm assuming he's putting 0 here because these are the same things. But maybe that's wrong assumption. So I'm going to put a to-do here. Check my assumptions on how the queue index works. What he does is each queue family index, you create one queue create info. Yeah, for each queue family index, you create one queue create info. Yeah, that makes sense. But if there were like multiple, so like if there was, I don't know, I might have to look into this a little bit more. Yeah, queue index. So the family index is this guy. And I assumed if these were different, this would also have to be different since it's now located at the next queue index. Oh, wait, I think I see what you're saying. So we have the family index, and then the queue index is basically like this group of families. I think that's how that goes. Could be wrong. So for each queue family, you get the first created queue. Okay, yeah. Okay, so there's one like queue, and then that queue has multiple queue families. Okay, this is fun stuff. That makes a little bit more sense though. So okay. So like if this was a data structure, it'd basically be something like we have our queue, and then we would have like our queue families, which is just an array of uint32s or something like that. And then this queue, you could potentially have multiple queues which contain multiple queue families. And we're attaching both of these to the same queue. I think that makes sense, yeah. Queue family is like feature set. And from the family, you get the queue itself, other way around. Oh, and from the family, you get the queue itself. You have queue family with an array of queues. Oh, okay. Well, yeah, okay. So it's just like array of structures versus structure of arrays. So queue family, you're saying... Yeah, but they're all equivalent, right? So you have your queue family. So if we have like graphics family, if I could type, this has multiple queues, right? We have n queues or whatever. But these are both just the 0th queue. So this would be like, oh, I see what you're saying now. That's not what I want to do. Okay. So each family has a list of queues. I see what you're saying. Okay. So basically, if we want to add another present family here, we would have to do like that. And that would add a new family to the list of queues for our present family. Okay, I think that's what you guys are saying. And if so, this makes sense now. Okay. And this would be our present. The queues are all of equal capabilities in the same family. Yeah, that's it. Okay, cool. Thank you. I appreciate the help. So it's just kind of hard trying to map all these data structures out and stuff internally when you have functions like this that don't really elucidate that much. But this makes sense. So we basically have structures full of queues. Each family has its own set of queues, and we can add multiple queues to that family. Okay. So let's just make sure this works still, and then I can move on. So we got that. It's all working correctly. Cool. Or at least we have no errors. I should probably make sure it shuts down correctly too. Okay, yeah, we're good there. So basically in the queue create info, you specify queue count. The queue index is which of the prior specified amount of queues you want to pick. So if we look at this create info. Okay, yeah, and since we're setting this to 1, we can only use index 0 because we only have 1 queue available in that specific family. But if we had 3 or 5 available, we could index higher and then set up where we want that to live inside that family. Okay, that makes a lot more sense. Cool. I should probably create some sort of data structure around this to help me manage all this complexity and stuff, because that would help me map it out so much better than just having this blob of code. But yeah, cool. Awesome. I appreciate that help. Let's see if we can move on to the next part. Our swap chain. Vulkan does not have the concept of a default frame buffer, which I guess is untrue, according to you, Implody. Maybe I'm incorrect on that, but dynamic rendering, we don't really, that kind of is like a default frame buffer, if I'm understanding that correctly, but that could be wrong too. I'll have to look more into that. Hence, it requires an infrastructure that will own the buffers we will render before we visualize them on the screen. This infrastructure is known as the swap chain and must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be another queue. That's great. Jomega, also for my new job, I need a UK job visa, so probably going to need to do an English test because it's not my official language in my country. Huh. I didn't know they made you do English tests for that. Dynamic rendering is the lack of existence of frame buffers. Okay. That is interesting. Swap chain is essentially a queue of images. Frame buffers are just metadata pointing to attachments on desktop. Okay, so not like the frame buffer in the OpenGL sense, where a frame buffer is just like a texture that you can, or just a thing that you can attach textures to and stuff, I guess. They're required on Tyler GPUs, though, which aren't used on desktop. Huh. Okay, so infrastructure is known as the swap chain and must be created explicitly. The swap chain is essentially a queue of images. Our application will acquire such an image to draw to it and then return it to the queue, and then it'll swap them. Okay, how exactly the queue works and the conditions for presenting an image depends on how the swap chain is set up, but the general purpose of the swap chain is to synchronize the presentation with the refresh rate. Nice. Not all graphics cards are capable of presenting images directly to a screen for various reasons. Cool, because you have it server-side rendering or something, I guess. Secondly, since the image presentation is heavily tied into the Windows system and the surfaces associated with Windows, it is not actually part of the Vulkan core. You have to enable another extension, the Swapchain extension, after querying for support. For that purpose, we'll first extend the isDeviceSuitable function to check if this extension is supported. We've previously seen how to list the extensions that are supported, so doing that should be fairly straightforward. Note that the Vulkan header file provides a nice macro, Vkhr Swapchain extension name that is defined as Vkhr Swapchain. The advantage of using this macro, is to prevent typos. First, declare a list of required device extensions similar to the list of validation layers to enable. Alrighty. Let's see. Maybe we should try and do this on our own. I'll see how far I can get. So let's go up here. We have somewhere up here, or at least I thought I did. Maybe I don't. Oh yeah, right here. So we have VK layer Chronos validation. Did I just, I guess, yeah. So we'll have a constant array of 1 for now, and this will be our device extensions. And I think he might have called that required. No, okay. So we need the swap chain, Vkhr swap chain extension name. And we basically want to do something similar to what we did for our validation layer support, which is what he's going to do next. Is device suitable? Okay, next create a new function, check device extension support. That's called from is device suitable as an extra check. Okay. Static bool, check device extensions. I don't want to deviate too far from the tutorial just because then it makes it harder for me trying to remap these things in my head. But I don't mind going and changing implementation details if we want. So check device extensions. Is that what he called it? Support. Okay. Let's just make sure we're calling it the same thing here. And go back there. Okay. Yeah, so he basically gets how many layers there are. And then you put them into here. So then you create a container, add them to the container, and then you just check to see if they're there. Okay, cool. So I'm guessing this is going to be similar. So we'll have our device extension count, which does he do equals? No, yeah. And then we're going to have VK device extensions, something or other. Nope. Let's see what he uses. Enumerate device extension properties. Okay. So we've got that. We're going to give it our physical device, our layer name, which, what does he use for that? No, I'm using a different thing. Enumerate device extension properties. What do I have here? Yeah, that's right. Oh, and he passes in null pointer for that. So I guess since we're not using a specific layer here, it doesn't matter. Okay. Give it that. Properties, which he also passes as null pointer. Okay. This is where it would be useful for me to actually look at the documentation and know what I'm doing. Then we allocate some memory, and then we actually put them into there. Oh, no, so you call this twice. Okay, I see. First time to get the count, and then the second time to actually put it in there. Okay, that makes sense. And what type is this? This is a VK extension property. Extension equals and properties. Okay. And then I'm going to go ahead and just grab that. That times that. Okay, and then we call the same function. And I don't think that matters anymore, does it? But maybe it does. Then we give it that. Yeah, so he gives the extension count again, which is kind of interesting. And that is the same. Okay. Let me just check chat real quick. I think OpenGL is the only sane choice. So it looks like you guys are having some interesting discussions. Mesh shaders, bindless, beyond bindless textures. Bindless textures are something I've been wanting to look into too. So maybe we can play around with that at some point with Vulkan, which would be kind of cool. Yeah. Yeah, I'm running into limitations with OpenGL, and that's the whole reason that I decided to start looking into all of this stuff. How's it going, Water Serpent M? Good to see you here. But yeah, I've definitely noticed that. It's like you want to do certain things in OpenGL, and it's just unnecessarily difficult to set up your data in such a way that you can just kind of like hand it to it and let the GPU figure stuff out, which is kind of annoying. Doesn't have to be multi-core rendering, just have the ability to put rendering on a different thread in its entirety is nice to have. That is also true. One of the very annoying things, OpenGL, you can kind of do that. Kind of. You can't put the rendering on a separate thread, but you can put your data transfers on a separate thread, which I've done with, I think it's like GL map range or something, and you can map like a permanent range where you can just use that and then put your data in there, and then it initiates the transfer whenever the GPU is ready, which is kind of nice. And I have done that. What limitations did you encounter, Tinspin? Are you talking to Implody or me? I think you're probably talking to Implody. Okay, let's keep going. So we've done that, and basically what he does is required extensions. I don't get why he does this as a set when we already have the array, but it is what it is. Oh, and then interesting. Okay, yeah, I'm not going to do it that way. I'm just going to do bool res equals true, and then we'll just go for int equals 0 until I is less than device extension count I++. And we can just look at our extension dot name. Actually, we'll just do a double loop here. Yeah, so we'll say for const char star required ext and what did we call that? Device extensions? See, I feel like we should have called this required, because that makes a little bit more sense to me. So we'll do that. And then we'll say if for int I equals 0 until I is less than that, and if string compare that with our required ext is 0, and then we found one, bool found ext equals false, break if not found, then res equals false, or I guess we could just return false, right? And then return true if we make it through there, which works fine. Okay, cool. So we basically loop through all the required extensions. If we don't find it, we break early and we leave. And now for our is device suitable, we just want to check that. So we want to go here, and we basically want to, after we find the indices or before, does it matter? Okay, so we basically just want to say bool extensions supported equals check device extension support. Okay, so if we do this, we should still be fine. Hopefully, I believe my GPU is capable of this. Okay, what do we do here? Okay, so that's not right. Why did that not get populated correctly? I'm assuming I don't have that many extensions. Did I just do the wrong type there? Nope, that's a uint32. Device null pointer extension. Is the device set up at this point? Wait a second. Oh, I should be passing in the device here. That'd probably help out. Okay, so let's do that. And we'll change that up. I'm guessing that was the source of our problem. And let's go back to here. And we'll just pass that through there. And then let's just change this function signature to take in a VK. And this is already a pointer, right? Yeah, that's just a type def to a pointer. Okay, so let's do that. Now we should be good. Cool. And we get no errors. So, okay, but we got a memory leak because I forgot to actually free that memory. Okay, so that is a reason to do this. Do that. And then we'll just do that. That, and just make sure we free that memory afterwards, which is our extensions. Okay, so now if we go, we shouldn't have any memory leaks. And we are memory leak free. Cool. Okay, so we got that. I've chosen to use a set of strings here to represent the unconfirmed required extensions. That way we can easily tick them off while enumerating the sequence of available extensions. Of course, you can also use a nested loop. Yes, the performance difference is irrelevant. It is. Now run the code and verify that your graphics card is indeed capable. It is. It should be noted that the availability of a presentation queue, as we checked in the previous chapter, implies that that swap chain extension must be supported. However, it's still good to be explicit about things, and the extensions does have to be explicitly enabled. Okay. Using a swap chain requires enabling the Vkhr swap chain extension first. Enabling the extension just requires a small change to the logical device creation structure. Make sure to replace the existing line when you do so, of course. Enabled extensions. Oh, looks like we're already doing that. Kind of. Wait, so create info. Yep, extensions.size. Or am I looking at something else? PP enabled, pointer enabled extension names. I'm such a child. That shouldn't make me laugh. Okay, and then that. Why is this already done for me? What did I, that's interesting. Wait, what's he saying? Using a swap chain, enable the Vkhr swap chain first. Device extensions.size. Okay, this is extensions. What's the difference between extensions and device extensions? Oh, okay, wait a second. So this is below creating a device? Or I'm looking in the wrong create info, aren't I? Yeah, okay. I see what's happening here. Where is my create device thing? I think it's... No, it's not that. That's a Vulkan function. Where do I create my device? I don't like this setup. Oh, this is, I'm looking in create instance. Okay, so if we go through create logical device, there should be a create info here. Okay, I see it. So then here we want to say enabled extension count equals device extensions dot size. And then we want to assign that pointer. Okay, and we can just give it this data. All right. And make sure to replace the extension count when you do so, which we did. Cool. Okay, so that should be fine. Make sure to replace, okay, yeah. Now, querying the details of the swap chain support. Tinspin at Games with Gabe. How's the voxel project going? Unfortunately, I have not gotten to work on it since I've been working on the animation editor so that I can hopefully finally make the next video on YouTube. Once I get that done, I do have a lot of ideas for things I've been wanting to try in the voxel game, animations, and I wanted to get into mobs and all that type of stuff. So we'll see. Yeah. I'm excited to get back into it once I finally get to a good point with the animation editor and stuff. Refined chicken, it definitely didn't make me laugh either. Okay, so let's see. Checking if a swap chain is available is not sufficient because it may not actually be compatible with our Windows Surface. Creating a swap chain involves a lot more settings than instance and device creation, so we need to query for some details before we're able to proceed. There are basically three kinds of properties: surface capabilities. Okay, that's interesting. Surface formats, pixel format, color space, available presentation modes. Similar to find queue families, we'll use a struct to pass these details around once they've been queried. The three aforementioned types of properties come in the form of the following struct and list of structs. Okay, cool. So this is basically just a structure we're going to use to carry around that information for what our swap chain supports. Yeah, I guess we'll leave these vectors. It really doesn't matter. Yeah. Okay, cool. We'll now create a function, query swap chain support, that will populate this struct. Lots of stuff here. Do we have a query? I think we do. Somewhere. I guess we don't. Okay. So this is, we're gonna put this below. I'm trying to figure out a good place to put this. Check for required EXTs. Where is that? Check device extension support. Okay, we'll put it down here. And I guess this is gonna be void. No, this is gonna return to swap chain support details. Okay. So all right, we're gonna call it that. Man, my mind is working extra slow today for some reason. I guess we should call that support. Today has been a long day. Okay, let's go. Check device extension support. Go down here and we'll place this guy down here. Okay. And that makes sense. We will just create the swap chain support details. And we'll do that. Cool. This section covers how to query the structs that include this information. The meaning of these structs and exactly which data they contain is discussed in the next section. Let's start with basic surface capabilities. These properties are simple to query and are returned in a single capabilities KHR struct. Okay, that's pretty easy. So get physical device surface capabilities. And this is our KHR. So we're going to give it our device. We're going to give it our surface. And details dot capabilities. And that should populate that. Cool. Let me just check chat real quickly. Tinspin, so am I implementing skin mesh animation? Not at the moment. Eventually I will, but there's a lot of things I've got to do before I can get to that point, most likely. So, and skin mesh animation, I think it's like, I'm not sure if that's the technical term because I've not done any sort of things with 3D animations, but bone-based animations, if that's what it's called. I don't know. Skeletal animation support is basically what I'm going to go for, I think. I'm not sure if there's a difference between skin mesh animation and skeletal or if it's the same thing. Okay, this function takes the specified device, basically fills this out. Makes sense. Next step is about querying the supported surface formats. Because this is a list of structs, it follows a familiar ritual of two function calls. Okay, so we call it, we get the count, we call it, we fill out our data. Okay, and this is our format count. So we'll do that. And then we say VK, what was that function called? Get physical device surface formats. No, I'm looking at the wrong thing. No, yeah, get physical device surface formats. Okay, and we'll pass it our device, our surface, our count, and null pointer first time. And then we'll go into here. This will be our Vkhr Surface format. Actually, I think we're probably just going to populate it into this details thing, so it doesn't matter too much. Yeah, we're probably just putting it into here. So we can just do that, which I'm assuming he does. Yeah, well, he does resize. Yeah, I guess I would want to do resize because reserve doesn't actually zero things out and everything. I'm pretty sure resize calls the default constructor. So a little bit different, but yeah. If anything was said towards me, I was away for like 5 minutes. All good. And Tinspin made skeletal animation. Now I'm doing voxels, so the other way around. Yeah. There's so many different avenues in 3D graphics that it's hard to choose which way you should go and what you should spend your time focusing on for a little bit. And you had a grasshopper in your room. Oof. Refined Chicken, how did you get into game programming or programming software dev? It really used to intrigue me, but I never found a good starting point. I was always interested in game programming specifically. And I think I started with a JavaScript. It was advanced games design in JavaScript or something in HTML. And I basically just read the book and like typed out the code on my computer and thought it was super cool. And just kind of went from there. Technically, I really started with like Minecraft command blocks. Like back in the day, this wasn't when they had all the if command blocks and while command blocks and the looping things. This was back when it was just like JSON stuff. But yeah, me and my brothers made a few Minecraft maps that had some cool like little tidbits and stuff that you could do. I think I made like a 3D printer by having some command blocks inspect the chest contents and then like printing blocks out and stuff. So that kind of got me started. And then I moved on from there. But yeah, there's lots of cool things you can do in programming. And I think the best part is find a project you want to do and then just try to do it. And then you can just kind of grow from there. Okay. And I need to turn my Steam notifications off. Remind me to do that before the next stream. Okay. So we've done that. We also need to call it again. That makes sense. So we call this again, except we give it our data pointer. So we populate that data. Make sure that the vector is resized to hold the available formats, and finally querying the supported presentation mode works exactly the same way. Okay, so then we do the same thing for present modes. Cool. Do that. Man, this is giving Java a run for its money and the level of verboseness in these function names, okay? Normally I am quite happy with that, but boy, this is pretty long function names. What is this called? Physical device surface present modes KHR. Physical device present modes surface KHR. Is that right? No. Okay, there we go. I must have typed something wrong. Okay, physical device. We're going to give it our device, our surface, device, our mode count, and null pointer, and then do the same thing. Then we want to say details.present.resize. And then we'll say same call and give it our details.presentModes.data. Okay. So we got all that. All the details are in the struct now, so let's extend is device suitable once more to utilize this function to verify that Swapchain support is adequate. Swapchain support is sufficient for this tutorial if there's at least one supported image format and one supported presentation mode given the window surface we have. Makes sense. Okay, so we're making sure the extensions are supported before we go ahead and try and do that. Okay, so is device suitable? F3 to change where we're looking for that. There we go. Okay. So if the extensions are supported, swap chain supported. I don't know what they call that. Oh, they get the details. Okay, and then they just check and see if that is not empty. Oh, and then they add that to the list. Okay, that makes sense. So we'll initialize that to false. Details. What do we call that? Query swap chain support. We give it the device. And then we can say that is adequate if we have at least one, not details, if we have at least one format. Oh, I guess we can just say dot empty. That's what he was doing there. If we have at least one of those, and if we have at least one present mode. So if it's not empty and that's not empty, then we have enough support, and then we just want to make sure we have an adequate swap chain. Okay, let's see if that runs. Looks like you guys are talking about some SIMD stuff. Interesting. I have to actually click run there. SIMD is something I'd like to eventually check out someday, along with many other things. Okay, cool. Not sure if you guys saw that interview with John Carmack that was released recently. I've been watching that, and it's just interesting seeing a lot of the things he talks about, his programming life, day-to-day stuff and everything in the early days. Very cool. If you haven't seen it, I think it's Lex Fridman. I've never heard of this guy until now, but if you get a chance, check this out. This guy right here, 2 days ago, 5 hours, but it is very insightful, and I have been enjoying it quite thoroughly. Just watch a little bit every night, which is kind of cool. So aside, but yeah, 5-hour interview, Tinspin. So you have seen it, yeah. But it's pretty good. Carmack interview is on your watch list. Yeah, I'm like an hour and a half into it so far, and it's just, I read Masters of Doom. I think that's the book. Let's just check. Masters of Doom. Yeah, this book. This is amazing. It was written in like 2004, I think. 2003. Very good book. Read it if you haven't, and I thoroughly enjoyed it. But yeah, saw the beginning and jumped to the end. Oh no. But I read read this book, and so watching this interview with John Carmack talk about himself is really interesting because it is he reiterates a lot of the stuff that you read about in here, but he gives additional insight, which is really interesting. Just kind of hearing about it from his perspective instead of the guy who was writing that book's perspective. It's just interesting. Yeah. More of a technical insight than a general audience kind of insight, which is kind of cool. But yeah, thoroughly enjoying it so far. I'm sure you guys will as well. Choosing the right settings for the swap chain. Another good Doom book is the Game Engine Black Book. I've been meaning to look into that. I have heard about this one, and I've seen lots of recommendations. Yeah. One of the things John Carmack mentioned in that interview too was coding games in assembly, and I thought it'd be cool to have, I guess Pico Game Engine is kind of like that, right? Pico Game Engine. Virtual machine and game engine created by Lexaloft Games. It's a fantasy game console that mimics the graphical sound. Okay, yeah, of the 1980s. So that's basically exactly. I think I might want to experiment with this a little bit because one of the things he mentioned was him and John Romero and some of the other guys, Tom Hall, they were all creating games once a month in assembly, which just sounds really interesting. I don't know. I feel like I'd like to give that a try at least 1 month, possibly many months, using something like Pico Game Engine where you create limited games and just kind of go based off that. But yeah. Let me just check. Kind of wish Game Engine Black Book and a modern AAA game engine. That'd be insane. Yeah. Why do BGR instead of RGB? Would 10K pages be enough for that? I guess I would say I don't know how the engine Black Book is, but Jason Gregory and Game Engine Architecture is so amazing if I spelled that right. But let's do the 3rd edition. This has been, yeah, I've got this, and I just go through it from time to time and just kind of read different sections depending on what I'm interested in, and this is amazing. I really like it. It is over 1,000 pages, and it still doesn't cover like a lot of the higher level concepts. It's mostly just like lower level stuff like input, engine details, initialization, destruction. That book is amazing. So I don't know how it compares to the Black Book, but very good. Don't ask me why, though. It's something you live with. RGBA is not always supported for Swapchains. Interesting. I guess that kind of makes sense, because why would you want an RGBA window? I know that's common in Linux, but like Windows, you don't really get transparent windows that much. So I guess that kind of makes sense. You have real-time rendering as hardcover. I want to get that one too. There's so many good books. Yeah. Steel Tree, I have to. It's like 1,200 pages. Yeah. Yeah. Very amazing. Okay, so let's continue with this. We still haven't even gotten to image views, guys. I think we're probably going to finish presentation and save this for next week. And then we'll get to drawing on the 4th week. And after a month, I'll have drawn my first triangle. So, yeah. But I guess that would just be 8 hours, which kind of makes... It's not too bad for the talking and stuff, too, in the middle. It's RGBA versus BGRA. Real-time rendering, your guide to reading 2K papers. Yeah. We need some books for physics like those, because right now the best thing we have for physics, I think, is real-time collision detection, which is great, but I don't think that goes into collision resolution, which is a huge part of actual physics stuff. And then I'm trying to think of the one that I did that actually had... Let's see if it pops up. Yeah, this is the one I read. Game development, how to build a robust commercial grade physics engine. Questionable. I followed the book word for word. I did end up with a physics engine. Was it robust? No. Was it commercial grade? Absolutely not. We need something better in this space. So it would be nice to have a much more thorough dive into that type of stuff, because everything I found so far is just like it's really hard to do physics well, though, I guess. So not too surprising. And Tinspin, what will the animation editor do? Move voxels? Talking physics, did you see the Jolt thing? I've not seen Jolt. And game physics in a weekend, that would be cool. In the animation editor, just for reference real quickly, let's actually pop open a new one here. It's a thing I'm working on for YouTube video specifically, so it's not part of the voxel game. So this is math animations. It was just, there were shortcomings with Manum, which I had been using for doing my videos, mathematical animations and stuff. And so I am developing this, which is kind of like a drop-in replacement. Actually, I have to turn something off because I kind of have it broken right now. So let's actually just comment that out. Broken, have been working on it. Oh, wait, Game Physics Weekend is a thing. Oh, huh. Or are you just saying that? I'm not sure. But yeah, so it's basically just like... I've been experimenting with 3D. That's what these circles are, and transparency and everything. So we've got like 3D transparent objects, which is kind of the latest thing. Where do I have that? Yeah. So if you rotate that and stuff, kind of got it. And it's got order independent transparency and everything. But yeah, this is basically what I've been working on. And this you can enter in LaTeX, however you pronounce it. And then you can go ahead and like generate new stuff. So if I were to change this to curly brackets, doing... I don't know whoops. Oh crap. I gotta fix that. So there's a few things I gotta fix and everything. But yeah, if I just like extend this again, I think I've broken, I've got a bunch of error codes. That's not good. I wonder what I did wrong here. And we will not find out. Okay, let's see if I can restart it. There's still some spotty stuff with like generating this stuff. Okay. So like I was saying, if we just change this to that, and then I hit generate. I don't know if that's valid LaTeX, but it should run it. Okay, yeah, looks like it did. Oh, and it looks like that's not valid because it just did nothing. How do I get a regular matrix in there, like curly braces? Because I just want to see if this works. It should work, but I'm still questioning a lot of stuff. B matrix, capital B, because that makes sense. Okay, so if I do capital B, just kidding. LaTeX is awesome, so not going to talk bad about it, but it should regenerate that. There we go, yeah. So it regenerates it. It creates SVG objects so I can do these cool write-in animation things. Just kind of interesting stuff. I've got a lot of work to do on this still, but I'm getting to a better point. But yeah, that's besides the point. You were just asking about that. Wanted to bring it up real quickly. We can stop that now, though. The demo gods, yes, absolutely. And so kind of like what Freya uses for you, like math YouTube tutorial sort of thing. Exactly, except I wanted that specific SVG support. And the more I'm working on this, the more I'm like, this is just going to turn into a game engine because that's basically what you need to do. It's the easiest way to do this type of stuff. But the timeline and everything had to be native, which is why I didn't use Unity. I'm also integrated it with FFmpeg to get like actual exporting to videos and stuff. So yeah, there's a few things that were just a little bit, it felt easier to just create it myself than to like use something like Unity. Yeah. I want to see what this is. Game physics in one weekend. What the heck? I had no idea this was a thing. Thank you, Implody. I really want to check this out now because, that is really cool. I'm going to have to check this out. Interesting. But yeah, let's go back here. And also GPU Zen series. Ray tracing gems, I've read different snippets from them too. There's Manum. What's wrong with Manum? Yeah, so I used Manum initially. One of the biggest shortcomings, which I've showed in previous streams and stuff, but one of the biggest shortcomings is it doesn't handle order independent transparency in 3D correctly. And then second biggest shortcoming, it's not real time, so you can't get immediate feedback on things like I was doing there, showing you guys like moving stuff around. Can't do that. And then the third biggest shortcoming is texture support is abysmal. Like if you want to do anything with 3D textures or 3D images, which they are in Manum, it's just, it's like pulling teeth. And so I got fed up with it and was like, it's going to be easier to create my own. And I've got the bulk of it out of the way. So you could see I had most of the features there. And the timeline support and everything too. So it's just, and I've got exporting the videos correct and everything too. So I'm on the final leg. I just have to get the 3D stuff a little bit more ironed out, and then it's works pretty good. But yeah, texture support was very annoying for me, and I was like, I've just got to do something a little bit with native support for that. Okay, anyways, what were we working on? We were choosing the right settings for the swap chain. We'll write a couple of functions to find the right settings for the best possible swap chain. There's three types of settings to determine: the surface format, which is color depth, presentation mode, conditions for swapping images to the screen, and swap extent, which is the resolution of images in the swap chain. For each of these settings, we'll have an ideal value in mind that we'll go with if it's available, and otherwise we'll create some logic to find the next best thing. The function for this setting starts out like this. We'll later pass in the formats member. Okay. Well, let's just copy that. So we're going to put this below our query swap chain support since it's all related. Copy that. Go down here, make that static. Okay. So each format contains a format and a color space. The format defines the color channels and types. So this means that we store Vkhr Alpha in that order with 8-bit unsigned integer for a total of 32 bits per pixel. The color space member indicates that if the sRGB color space is supported using the nonlinear KHR flag. Note that this flag is used to be called nonlinear KHR in old versions of the specification. For the color space, we'll use sRGB if it's available, because it results in a more accurate perceived colors. It also pretty much the standard color space for images like the textures we'll use later on. Because of that, we should also use sRGB color format. So BGRA. Okay, so basically just looking for a pixel format. Doesn't sound too difficult. Let me actually write this out, because writing it out helps out a little bit. So for const, let's see, Vkhr Surface format KHR. All right. And then we're going to check and see if we have the correct color space, which is the format. Oh, wait. So the color space is sRGB nonlinear KHR, and then that format. Okay. So that's format. Is it BGRA? Is that what they were going with? Yeah, BGRA. Okay. Oh, and there's no underscores there. Man, I am like slowly getting too tired for this. I've done a lot of stuff today, which it's just like physical stuff, so not like mental stuff. So this shouldn't be too hard, but it is. Color space equals, and we want to do equals there. The VKKHR S norm or S color space. No, okay, VK color space sRGB nonlinear KHR. Okay, so if we have that, that is our preferred format. And we just return that. Okay, simple enough. And we copy it. So we return a copy of that. If that fails, then we could start ranking the available formats based on how good they are. But in most cases, it's okay to just settle with the first format that's specified. Okay, so basically if it fails, our super fancy selection scheme just says return the first one then. Okay, works for me. To do, have some sort of selection hierarchy to choose the next best format. Okay, presentation mode. So the presentation mode is arguably the most important setting for the swap chain because it represents the actual conditions for showing images to the screen. There's 4 possible modes: immediate, FIFO, Fifo Relaxed, mailbox, and those are it. Okay, so immediate images are going right away. Okay, swap chain is a queue where it takes the one from the front and then it renders to the back. If the queue is full, then the program has to wait. Okay, so this is similar to VSync. The moment that the display is refreshed is known as a vertical blank. Okay. Fifo Relaxed, this mode only differs from the previous one if the application is late and the queue was empty at the last vertical blank. Instead of waiting for the next one, it's transferred right away when it finally arrives. This may result in visible tearing. Wait, okay, let me read that again. Instead of waiting for the next V blank, the image is transferred right away when it finally arrives. Okay, so instead of skipping a frame, you would just do it like in the middle of the frame. Gotcha. This is another variation. Instead of blocking, the images that are already queued are simply replaced with the newer ones. This mode can be used to render frames as fast as possible while still avoiding tearing, resulting in fewer latency issues. This is known as triple buffering, although the existence of 3 buffers alone does not necessarily mean that the frame rate is unlocked. Okay, interesting. Mailbox. Let me just check on chat real quickly. Niyako, how's it going? Good to see you. How's progress going? Already got a triangle rendered? No, we're still quite far. We have 2 more. Didn't mean to click on that, but we have 2 more whole things to go through before we get to a triangle. We're closer. We're on presentation mode here. Tinspin, I just saw why C++ scares the crap out of me video. My solution is int float arrays only and C syntax. And I only use the namespace, stream, and string from C++. With arrays, you avoid cache misses and you can access data atomically from multiple cores. Well, the thing that I don't like about C++ is all the extra stuff you have for like constructors, destructors, all those rules, all the rules for assignment, operator overloading, moving R values, L values, all that stuff that you have to worry about. It's good to know about that stuff, but I don't like having to worry about it. So you stick with plain old data objects a lot, and it reduces a lot of that. If you use more of a C style, it reduces a lot of the headaches, in my opinion. You could write books about Vulkan swap chain handling. For the last cache misses, you need to know the cache size and then go for array of structure or structure of array. Okay, so only the FIFO mode is guaranteed to be available. So we'll again have to write a function that looks for the best mode that's available, of course. So choose swap present mode, and we're going to give it the available present modes. We'll put it down here. Go ahead and put that up there. Okay, and we return FIFO since that's available. Personally think that mailbox is a very nice trade-off if energy usage is not a concern. It avoids tearing while maintaining a fairly low latency. On mobile devices where energy usage is important, you'll probably want to use FIFO. Okay, so we're going to do mailbox. Otherwise, we stick with that. Makes sense. So we'll say for in that, say if present mode dot. No, I can't do dot access on any of that. Oh, it is just a thing. Okay, I see. Present mode mailbox. We will return that. Okay, so we return that if we can, otherwise we return FIFO. And that leaves only one major property for which we'll add one last function, which is the swap extent. That's the resolution. It's almost always equal to the resolution of the window. Makes sense that we're drawing in pixels. More on that in a moment. I'm assuming he's going to talk about DPI stuff for phones and everything. Could be mistaken on that though. Okay, let's do that. And let's do this. Okay, and we'll go back down there. All right. Man, I wonder what happens when the window resizes. Do you have to redo all this? And I'm afraid that the answer is yes. Okay, the swap extent is the resolution of the swap chain images. Yep. The range of the possible resolutions is defined in the surface capabilities. Vulkan tells us to match the resolution of the window by setting the width and height to the current extent member. However, some window managers do allow us to differ here, and this is indicated by setting the width and height in the current extent to a special value, the maximum of uint32t. In that case, we'll pick the resolution that best matches the window within the min and the max bounds, but we must specify the resolution in the correct unit. GLFW uses 2 units when measuring pixel sizes, pixels and screen coordinates. For example, the resolution that we specified earlier when creating the window is measured in screen coordinates, but Vulkan works with pixels. Yeah, so DPI stuff, yeah. So the swap chain extent must be specified in pixels as well. Unfortunately, if you're used to using a high DPI display, screen coordinates don't correspond to pixels. Instead, due to the higher pixel density, the resolution of the window pixel is larger. So Vulkan doesn't give us, we can't use the original window or width and height. Instead, we must use the frame buffer size to query the resolution in pixels, which makes sense. Okay. Okay, so we're going to check and see if it's not max. Wait, let's read up what was he saying here again, just real quickly. Vulkan tells us to match the resolution of the window by saying that. However, some window managers allow us to do this differently, and it's indicated by setting that to the max. Okay, so if they tell us that the max, that the width is max, then we just return whatever the current extent is, and it does it on its own, I guess. Okay. So if dot that. Oh no. Okay, wait. So if that does not equal that, we return the current extent. Otherwise, we get the actual extent. Okay, so we get the frame buffer size, and then we cast that to a uint32t. Okay, and then we clamp it to the min and the max. Okay, nothing too crazy there. So we do that, glfw, get frame buffer size. I think we have our window there, and then we can just give it that. And then we just want to say that. I guess we could just do this. This is just XY, I guess. Yeah, just XY. Cool. Width, height. So we do that. After we get that, we just want to clamp it. So that equals, yeah, I'll just use GLM's clamp. X min max. So, and then min is going to be our capabilities dot current extent, or I guess, and then capabilities dot max image extent. I'm guessing we probably want to do dot width. Yeah, that makes sense. Okay, we do that. Height, same thing, just do that and that and that, which is essentially what he's doing there. Okay, cool. And then we just return that. All right, cool. That's not too bad. The clamp function, yeah, cool. So creating the swap chain. Now that we have all of these helper functions assisting us with these choices, let's go ahead and create the swap chain. So creating a create swap chain function that starts out with the results of these calls and make sure to call init Vulkan after the logical device creation. Okay, so we create the swap chain after we have our device, which makes sense since we have to make sure that our device has all the capabilities that we need. Okay, so we'll go down here. Now I can say I've created a swap chain, so that's cool, right? I don't know if that's cool or not. Create logical device. Let's go ahead there. And then create logical device. And let's jump into here. Cool, so now we just have to call everything in the correct order. So we get the swap chain support details, we get the surface format, we get the present mode, and we get the extent, and then I'm assuming we use all that stuff to set it up. Query swap chain support. Do we pass, does he pass device? No, we just use physical device there. Okay. We want to get our extent and a few other things. What did I call this? Get swap chain. What did I call this? Choose swap. Okay, there we go. Present mode. So we want to do this. Present modes details dot present. Okay. And that returns that. Okay, so we got that, and choose swap surface format. Okay, or format mode KHR. Nope, that's wrong. What does that return? Surface format. Okay, so we got that, and then we want our extent. Okay, we passed that, our capabilities, which is just our details.capabilities. Okay, so we've got all that information. Cool. Aside from these properties, we also have to decide how many images we want to have in the swap chain. The implementation specifies that the minimum number that it requires. Okay, so based on what capabilities we have, we already know. So that's our... Okay, and we're just setting it to that. However, simply sticking to this minimum means that we sometimes have to wait. Therefore, it's recommended to request at least one more than the minimum. So we have double buffering, at least, I guess is what that means, if I understand that correctly. Okay. We'd also make sure not to exceed the maximum number of images. So 0 is the special value. That means that there is no maximum. So if we have max image count greater than 0 and image count is greater than max image count. Okay, so we just want to make sure. Oh, I see what he's doing. Let's go back here. So if okay, so if that happens, we just set it to be that so that we don't exceed the maximum we're allowed to do. Cool. As is tradition with Vulkan objects, creating the swap chain object requires filling in a large structure. It starts out very familiar. VK swap chain KHR. Yep. Swap chain. 0 initialize that. And I spelled that wrong. There we go. Again. So we set the type, we set the surface, the minimum image count, image format, color space, extent, array layers, and image usage. Okay. Oh, and I guess this is our create info. Oh, create info, KHR. Swap chain create info. Okay. So our type is some long thing. VK structure type swap chain create info. Structure type swap chain create info. Okay. Dot min image count equals that. Surface. We have our surface somewhere. Where did I put my surface? Wait, did I call it something? Oh, they probably just called this surface. Okay, so equals that. No, that's not what they called it. Surface format, present mode, extent. Okay, where are you getting surface from then? Oh, we have surface right up there. Oh, wait, no, I just called that surface mode. Okay. Oh, and I have something called surface. That's a global object. Okay, that makes sense. That can be confusing. All right, min image count, image format, image color space. I guess that would be what our present mode or surface mode, one of those two. surface format dot format. It does not like that. Did I spell that wrong? Oh. That would help. Okay. Man, I am really losing steam here. Okay, image color space. Create info.image color space equals this. That. We also want the extent, the layers. Which I just called extents. Layers equals 1. And image usage is color attachment bit. Interesting. The image array layer specifies the amount of layers. This is always 1 unless you're developing a stereoscopic 3D application, which I probably will never do that. The image usage bit field specifies what kind of operations we'll use the images in the swap chain for. In this tutorial, we're going to render directly to them, which means that they're used as a color attachment. Oh, okay. It's also possible that you'll render images to a separate image first to perform operations like post-processing. In that case, you're going to use destination bit instead and use a memory operation to transfer the rendered image to a swap chain image. Interesting. Okay. Let me just check chat real quick. Surface mode was interesting spelling of surface format, to be honest. Yeah. Well, what is the function called? Choose swap. Oh, yeah. I don't know where I got mode from there. I think it's because in here. No, yeah. I don't know where I got mode from. That's just my brain falling asleep on me. What's it warning me about here? Is unscoped. Yes, it is unscoped. Okay. So what's he say here? Yeah. Next, we need to specify how to handle swap chain images that will be used across multiple queue families. That will be the case in our application if the graphics queue is different from the presentation queue. We'll be drawing on the images in the swap chain from the graphics queue and then submitting them on the presentation queue. There are 2 ways to handle images that are accessed from multiple queues. Man, this is just like so much information. Oh, and this goes on for quite a while. Man, this is a lot of information. I don't like how we do this multiple times too. Okay, so he's just changing the modes based on that. Yeah, I don't like why we do this multiple times, but okay. And we'll pass in that physical device. Okay. Never default to exclusive. That can go very bad for performance when using images, like very bad because compression will be non-existent. Is that what he does? Wait, so what would you default to? So he's saying if they're not equal, which is the common case. No, this is the non-common case. This is the common case. Interested what you would default to then instead of exclusive. Oh, I guess you could just default to concurrent then. This is how to handle sync. Yeah. Well, I know that's why it's kind of weird because he's doing concurrent here where they're not equal. Wouldn't that be exclusive and then this would be concurrent? Or no, yeah. Wouldn't this be exclusive and this would be concurrent? Because if they are the same queue, oh wait, no. Never default to shared. Okay. Which he doesn't mention here. So yeah, concurrent shared is bad. Okay, yeah. So that's why, so concurrent is here, which is in the non-default case, and then exclusive is here. You're tired as well. Totally understand. Don't worry. Yeah, I get it. Okay, so let's do that. If indices dot graphics family does not equal present family, then we're going to say this is shared or concurrent. Yeah, except that's not present mode. That is image sharing mode. Okay. And then Q family index count is 2 since we have 2 Q families and we set it to that. Okay. So then and we would set that to just that. No, that. Oh, that's why he creates that array there. I was wondering what that was about. Okay. So we'll do this. I did not know you could do this in C++. Because this is not a const expr. Oh, no, it is a const expr. Okay, because we're specifically setting that. Okay, that makes sense. So this is just 2. Okay, so we do this indices.graphics, indices.present. And we'll do that. Else we will say that equals exclusive. And I don't have to worry about that stuff because it's already zeroed out, which is what he does here anyways. Okay. So this is drawing the images on the swap chain from the graphics queue and submitting them presentation queue. So this is just handling synchronization, like you were saying. Mask bubble, what are you working on right now? Trying to draw a triangle. Nowhere near that yet, though. This is Vulkan. I'm just kind of delving into Vulkan and learning it a little bit. But yeah. Sharing mode. Thought shared concurrent is fine for buffers. There are no layouts in those anyways. Might be a problem on transfer DMA queue, though. Okay. An image is owned by one queue family at a time. Ownership must be explicitly transferred before using it in another. This option is the best performance. Images can be used across multiple queue families without explicit ownership transfers. If the queue families differ, then will you be using the concurrent mode to avoid ownership? Okay, so then we just like set those. So pre-transform. Oh, cool. Okay, so you can just tell it to flip pixels and stuff, which is interesting. And we'll just use whatever the current transform is. What did I call that? That is our details. I guess surface format, maybe? No, that is our details. Dot that dot transform. Okay. The composite alpha field specifies if the alpha channel should be used for blending with other windows in the window system. Oh, cool. So you can do window blending. You'll almost always want to simply ignore the alpha channel, hence opaque. Yeah, makes sense though, because you don't want opaque windows, or you don't want transparent windows, I guess. Not geometry though. That is composite alpha opaque bit. That's not what I want to do. Okay, cool. The composite alpha, yep. I don't like how he does the code, then the explanation. The presented mode member speaks for itself. Okay. If the clip member is set to true, that means that we don't care about the color pixels that are obscured, for example, because another window is in front of them, unless you really need to be able to read these pixels back to get predictable results, enabling clipping. Okay. That is also good to know too, though. So present mode and then clipped. Oh, I think that's where I got mode from. Okay. Almost there at the end of this section. The present mode. Okay, yeah. So then swap chain. And then the old swap chain. With Vulkan, it's possible that your swap chain becomes invalid or unoptimized while your application is running. For example, because the window was resized. In that case, the swap chain actually needs to be recreated from scratch, and a reference to the older one must be specified in this field. It's a complex topic that we'll learn more about in a future chapter. For now, we'll assume that we only ever need one swap chain. Okay, and then we need a object to handle that. So vk null handle. All right. Now we can finally create the swap chain. Finally, hopefully. And then we'll be done with this part, at least. Okay. It is amazing the amount of stuff you have to do to get to a triangle. Man, I am so glad that I've used OpenGL all this time to handle so much stuff for me. You want transparent windows rarely? I mean, Windows, I don't know about Mac. I think Linux might have transparent windows sometimes. Ignore old swap chain. It's an optimization for move semantics. Gotcha. Okay, so it's now as simple as calling create swap chain. Cool, easy. And then we want to assert that it's correct. So we'll say, I think it just returns uint32. Result equals vk create swap chain. And we'll give it our device. Create info. I might need to, yeah. Okay, that's better. Null pointer. And our swap chain. Why does it not like that? Do we need our logical device? Yeah, we need logical device. Okay. So we can do that. And that should create our swap chain and fail if we don't. The parameters are the logical device. Yep. And then we need to destroy it too. Of course. Free. Do we need to destroy it before anything else? Before, should be cleaned up before the device. Okay. And we'll give it that. We give it that and null pointer. Okay, cool. Now run the application, make sure that it works. At this point, you get an access violation. Okay, if at this point you get an access violation error or see a message like that, then see the FAQ entry about the Steam overlay layer. Oh, that's great. Try removing the create info image extent with validation layers enabled, and you'll see that one of the validation layers immediately catches the mistake and a helpful message is printed. So we'll try both of those things real quickly. God, that's a lot of boilerplate. It's really insane. I agree. Is this C++? It is. It's a very C style of C++ because I prefer coding closer to C. And I'm trying some new things here too with like the naming. So I'm not using namespaces right now. But yeah, C++, but kind of like C. Let's also check that thing too. He said if we move the extents, if we remove that, we should get an error reported to us. Let's see if that's true. Do we get an error? We do get an error. And I guess this is very helpful. Let's see. I wish it was formatted nicer. Extent. It's illegal. The Vulkan states image extents member with width and height must both be non-zero. Cool. Okay. So it does indeed tell us that we broke something. Let's make that smaller now. Yeah. Okay, cool. So everything's going right and we don't get any problems destroying. We don't get any problems destroying. Awesome. Retrieving the swap chain images. The swap chain has been created, so now we need to get the images. We'll reference these during the rendering operations later. Add a class member to store the images. Okay, so we can do this. Almost there. I don't think I'm getting to that third section today because I am like about to fall asleep right here. Let's see how this works out. I'm actually going to do that. I don't know. It really doesn't matter. We'll do a vector. That's fine. Maybe I'll change my later. The images are created and they'll automatically be cleaned up once the swap chain is destroyed, so we don't have to add any cleanup code. Cool. I'm adding the code to retrieve the handles at the end of the create swap chain function right after that. Retrieving them is similar to the other times we retrieved an array objects, so first time for the count. Remember, we only specified minimum number of images, so the implementation is allowed to create a swap chain with more. That's why we'll first query the final number of images with that, then resize it, and then get them. Interesting. Let's go down here. Okay, and let's go down right here, right after we create that, and we'll say uint32 number of images equals vk. I guess it's vk get swap chain images. Yeah. And we want to get it for our logical device and the swap chain that we just created. And we want to give it number of images, which I'll fix in a minute. And that's null pointer first time. So we'll do that. That. And then we can say same call after we resize. What do we call it? Swap chain images. Yeah. Resize to that. And then we'll give it that data. Cool. Yep, exactly the same thing here. Cool. Last thing, store the format and extent we've chosen for the swap chain in member variables. We'll need them in future chapters. Okay, easy enough. So we just want to store this and that. I'm going to go ahead and just copy that though, because I know I'm gonna forget it. Let's go up to static. Let's just go to the beginning of the file. Right up here with the rest of these. Okay, and then we can just semicolon that and semicolon there. And we are good. Let's go ahead and just kind of swap chain stuff, because I might want to abstract all this into separate files, and this will help me do that. So we got our swap chain stuff. These are our queues. We've got this surface too. Is that part of that's? I think that's part of that. We've got our queues. We have our device stuff. And then we have, these are just general stuff. Okay, and this is Windows stuff. And this is general Vulkan stuff. Okay, I like that. You can kind of see everything starting to abstract itself, which is nice. You still have the Rockstar error thing. Yes, it is still there, unfortunately. We now have a set of images. Cool. How long is this? Oh, it's not too long. Okay, I guess we're going to do image views real quickly too. Oh, man, I'm debating it because it's been 2 hours already. Cool, so no failures. We're good there. Oh, it's not that long. We're going to do this. Okay, so to use an image, including those in the swap chain, we have to create an image view. It's literally a view into an image, and it describes how to access the image and which part of the image to access. So it should be treated as a 2D texture depth texture without any mapping levels. Makes sense. We will write create image views that creates a basic image view for every image in the swap chain so that we can use them as color targets later on. So we want our swap chain image views. All right, works for me. Writing Vulkan as an OpenGL dev feels like writing a driver. Oh man, it really does. It's just insane, the level of detail that you have to write. But it gives me a new respect for the guys who created OpenGL and the guys who create GPUs and stuff and all the APIs It's a lot of work. So I really appreciate the guys who have created these abstractions for us so that it's not as difficult as this every time. Driver devs start laughing. So we want to create the create image views function and call it right after the swap chain creation. Where do we have create swap chain? Somewhere in here. Oh, right there. Okay. And I feel like that should be below surface, but it's what it is. Okay. Go there, and then we will do that. Well, actually. And fix that. Cool. And then we want to do that after we create the swap chain. Alrighty, jump back into there. And now let's just blast through this real quick. So we need to resize the list to fit all the images. What do we call these? These are swap chain image. Okay, resize. Easy. Next, we set up a loop to iterate over them. Okay. Hey, thank you, Flat Boulders, for cheering. Yes, Flat Boulders. Did you say something too? For your hard work learning Vulkan. Oh, I appreciate it. I was seeing if you had said something else too, but thank you. It is very hard. Mad respect for people who enjoy this stuff. I don't know. I might enjoy it. It's hard doing stream and learning this stuff at the same time to try and keep it all in your head, but yeah, it is interesting. Laughs in assembly. Let's just check that. Okay, cool. So let's keep going through here. We're so close. I equals 0. I usually don't use size t. I usually just cast it to an int because it'd probably be a problem if it was 60 bigger than 32 bits anyways. But yeah. Okay. The parameters are specified here, and we want to do the swap chain images, right? Yeah, that was right. Okay. The first few parameters are straightforward. We have more create info structures. Great. Create image view create info. Okay, we got that. No, vk create image view info. Am I doing that wrong? I must be. Image view. Okay. Image view create info. There we go. That's the right one. S type equals vk image view create info type, whatever that is, structure type. Yeah. S type structure type makes sense. We set it to that. All right. The view type, it's a 2D view. So view type and format field specifies how the image should be interpreted. View type, it allows you to treat images as 1D, 2D, or 3D textures or cube maps. Cool. So view type is texture 2D. No, that's not what I want. What's it called? VK image view type 2D. And the format is the swap chain image format. What was that? The swap chain image format. Yeah, where is that coming from? I think I created this earlier and he said to make that. Yeah, okay, I think that's probably what one of these things are. Wait, let's go back in the tutorial real quickly. This is why I shouldn't name things myself, because then I just get confused when I do stuff like this. All the way down here, what does he say? Yeah, okay, so swapchain image format is the surface format.format, and swapchain extent is that. So let's go ahead and rename these real quick. And swapchain extent. Oh, wait. Oh, no, I need to go back again. And swapchain extent. Okay, and he's doing the extent. So this really didn't matter. This does, though. So I need to pay more attention. Swapchain extent, swapchain image format, and this is that. Okay, and let's go back up to where that was defined. Somewhere up here. I just wanted to be taken to the top. Okay, let's go up here. So that was down here. Okay, so this is actually VK extent 2D, swapchain extent, and this. Okay, yeah, surface format is swapchain surface format. Okay. So let's go ahead. Lost my key combos there. F3. No, not going to find it. I named that wrong then. Let's go back. Where was I? Swapchain image format. Okay. Almost there. Not surface format, image format, even though it's a surface format. It is what it is. Okay, so if we go back down, that's there. And swapchain image format is, so I have this at the wrong thing, I guess. Let's go back down here. Yeah, I must have set that to the wrong thing. Okay, wait, let's check this again. Surface format.format. What's this saying? No suitable from surface format KHR to VK format. So I'm definitely doing something wrong here. This should be surface format.format. Okay. Oh, and this is a VK format. So yeah, I'm definitely doing something wrong here. I should pay much more attention than what I'm doing. So this should be this. And I assume, yes, I did set this to the wrong thing. So this was our surface format. Which, what does this return? Okay, so that's that. And then we need to say swapchain surface format. Or swapchain image format. Okay. Is that dot format. Okay. And now we're good there. Finally. Cool. Now moving on. It's like 10 minutes of just renaming stuff. Okay. So we got that done. The components field allows you to swizzle the color channels around. For example, you can map all the red channels to a monochrome texture. You can map out constant values of 0 and 1. We'll stick to the default mapping. Makes sense. Okay. Create info dot. What was it? Format.r or something? Yeah. Components.r. VK swizzle identity. Okay. And we just do that. R, G, B, and A. The sub-resource range field describes what the image's purpose is and what part of the image should be accessed. Our images will be used as color targets without any mapping. Okay, so sub-resource range. Let's also just break this up a little bit. Sub-resource range dot aspect equals, and he said that should be a VK image aspect color bit to access it as a color bit. And then base, okay. So that's 0. And dot. Okay, so we've got that number. Okay, so the number of levels, we have 1. And we have our base array level. It's 0. And we have layer counts. We have 1. Okay. If you were working on stereographic 3D application, you'd create multiple layers for the left and right. Oh, so stereographic is just like VR headset. Okay. So creating the image view is now a matter of calling create image view. We just do an assertion, and then unlike images, the image views were explicitly created, so we need to destroy them. Okay, so we're almost there. So we just need to say uint32 result equals vk create view. We give it our logical device. Create info. Allocator image view, which we are going to store in vk, or actually, I guess just swap chain images or views I. That should work fine. And is that what he does? Yep, that's what he does. Cool. And then we'll just say, make sure that was a success. And if it's not, we assert. Great. And then we just need to free those. So we go for that. We want to say vk destroy image view. And just do that. Okay, cool. Simple enough. And let's make sure this works. It's not working. That's not good. Discovered this Vulkan stream just passing through. Well, nice to see you. Nestle, I'm not going to be able to say it. Nestler's reagent. That and memory transfers, like the usage of staging buffers. And there's lots of chat going on. Gnarly Quack, ahoy, rendering triangles yet? Nowhere near it. I'm happy with what we've done so far, though, I guess. We did change the name of this, didn't we? But we have a swap chain created that we can't display anything to yet. But it's created, so that's a good thing. Okay, and it destroys successfully too. Great, okay. Awesome. We are going to commit this, and then I am going to sign off for the night because, man, that was a pain. Create the swap chain. Okay, so in this stream, we followed the next part of this tutorial, which was creating our swap chain for presentation. Oh man, and there's just so much stuff to this. I am afraid to open up the graphics pipeline basics. Yeah, man, this is going to be fun. But it's going good. I somewhat understand what's going on. I'm sure I have a very surface level understanding of all this stuff, and hopefully it'll get deeper as we go on. Let me just check chat out real quickly. How do you eat an elephant, right? Agreed. Okay. Well, guys, I think that's it for this stream. Hopefully you enjoy watching me just kind of struggle through all this tutorial and these very verbose things. I'm surprised we haven't had any major errors yet. It's like just been syntax errors and whatnot. But I guess I am following the tutorial exactly, so it should hopefully go easy. Sasha Willems' Vulkan examples are a nice reference. Yeah, nowhere near being able to look at examples and comprehend any of that stuff yet. So we're just in the very basics, getting this stuff up and running. But yeah, it was great. And yeah, I appreciate the help, Implody. It was great having all you guys giving me tips and everything. I'll probably be back next week, either Friday or Saturday, 6 p.m. CST. If you're in the Discord, I'll send a notification whenever I'm about to stream. Really appreciate all you guys being here, though. And I'll see you guys next week. All right. Thanks.